Okay, welcome to ACT Prep Day 20. You should have your purple bell ringer out so that you can start to work on this bell ringer activity. This one is about rates. We got miles per hour here. Again, when you're starting to be given measurements or rates, you need to be very careful that you're given the exact same ones. That they don't change it on you, like they might give you miles per hour and then miles per minute, things like that. So that's the first thing you want to check here. So take a moment, pause the video, work on the bell ringer activity. When you're done, unpause, and we will check your answers. Okay, welcome back. Let's check these answers. So if Ross drives 2 hours at 65 miles an hour and then an hour and a half at 50 miles an hour, how many total miles does he drive? This one's pretty simple. So 65 miles in 1 hour. If you do 2, that's going to be what, 130 miles? And then if you look at the 1.5, I actually can do this math in my head. Because in 1 hour, I'd drive 50. In 30 minutes or a half hour, I'd drive 25 miles. So that's 75. So 130 plus 75 is going to give you 205 miles. Here, they've got 22 widgets per hour. What's a widget? It's a made-up word, just so that you're doing a math problem. How many whole widgets are produced in 45 minutes? There's 2 different ways you can do this. This one is going on ahead and converting that 45 minutes is equal to 3/4 of an hour, or 0.75. Another way that you can do this is to set up a proportion. You could say 22 widgets. Oops, sorry, trying to use my pen. 22 widgets is to 60 minutes. We've got to convert that in 1 hour to 60 minutes since they're asking us about 45 is equal to X over 45 minutes. That's going to give you 16. But again, if you recognize that 45 minutes is 3/4 of an hour, or 0.75, you just multiply by 0.75 and you get 16. So day 20, we're going to talk about matrices. Matrices, you might have had a little bit of this in Algebra 1, but you're really going to learn about this in Algebra 2. Again, I know I sound like I'm selling you on a TI-84, and I am, because they're worth it. The TI-84 does matrices for you, and this is always a math that I can do, but I have to relearn it every time. It allows us to solve multiple equations really, really fast, and computers have allowed us to solve these equations because of matrices. And I had my oldest son. He could actually solve a matrix problem much faster than I could because I had to do it by hand. And he knew how to use the calculator and key it into the calculator and add, subtract, multiply, and divide matrices with the calculator. And he would amaze me at how good he was. So would definitely encourage you that. But a matrix is simply an array of numbers. If you've seen the movie The Matrix, that's exactly what it is. It has all the numbers coming down. It's just an array of numbers in the background. And that's what it is. The numbers are set up in rows and columns. You can add and subtract. This is very, very important. You can only add and subtract matrices if they are the same size. And we calculate the size of a matrix by the number of rows and columns. So if it has 2 rows and 2 columns, it's a 2 by 2. If it has 3 rows and 4 columns, it would be a 3 by 4. So they have to be the exact same size for you to add or subtract them. If they're different sizes, you cannot add and subtract them. You'd say it's impossible. I can't do it. So here's an example of some matrices. We've got matrix A, matrix B, matrix C. If we looked at matrix A, we've got 3 rows. We have 3 columns. This is a 3 by 3. B is 3 rows, 3 columns. This is a 3 by 3. C has 3 rows, but only 1 column. It's a 3 by 1. So if I asked you to add A and C, your answer should be, I can't do it. Why? They're not the same size. You got a 3 by 3 and a 3 by 1. I can't add them. Subtract. Do A minus C. I can't do it. Why? They're not the same size. Add A plus B. Can you do it? Yes. Why? Because they're the exact same size. They're both 3 by 3s. So let's look at adding and subtracting. Excuse me. Like I just said, A and B are the only two we can add and subtract because they are the exact same size. So if we do A plus B, and this is really, really simple, but again, I tend to forget this. All you're going to do, we're going to do corresponding numbers. If it's a 3 by 3, we are going to end up with a 3 by 3. Okay? So we're just going to take corresponding numbers. This is row 1, column 1. So we're adding 1 plus 2 gives me 3. It goes in row 1, column 1. I'm going to change the pen color. Now we're going to go here. Row 1, column 2. 3 plus 3 gives me 6. Change again. Row 1, column 3. 6 plus 4 gives me 10. Hopefully you're seeing a pattern here. Okay. Now we've got row 2, column 1. Add those together. We get 5. I'm going to try to not change pens here. 6. So we're not sitting here all day. Row 2, column 2. 2 plus 5 gives me 7. I'm going row 3, column 3. 2 plus 6 is 8. You see they go in the corresponding columns. And here we get row 2, column 3. 3 plus 1 gives me 4. And 3 plus 4 gives me 7. And that's my answer. This right here, this is my exact answer. Okay? Now, let's look at A minus B. So if we're subtracting, we're going to get the same thing again as well. It is going to be a 3 by 3. Because again, they have to be the exact same size. And it's going to result in the exact same size. And we're going to do the exact same thing that we did before. Corresponding positions. So row 1, column 1 with row 1, column 1. But this is A minus B. So we take the A and subtract the B. So this is 1 minus 2, which gives us a negative 1. If it was B minus A, we would go 2 minus 1. But it's 1 minus 2 is negative 1. So then we switch over here to row 1, column 2. 3 minus 3 gives me a 0. And then 6 minus 4 gives me 2. And again, you keep going. I'm going to use the same pen color. 3. And you might want to have colored pencils on something like this. It does help. 1 and 3 is going to give me negative 2. 3 and 4, negative 1. And let's finish with the red one. So 2 minus 5 is going to give me negative 3. And 2 minus 6 is going to give me negative 4. And again, that's my answer. That matrix is 100% the answer. Okay. You can see.
Miss Knox, please come to the annex office, Miss Knox.
Tried to color code it because I think it makes it easier than how the PowerPoint does it. Same matrix answers, matrices, but now we're going to get into multiplication. Now doing a 2 times A, this is really, really easy. If we have A, again, it's a 3 by 3. Okay. The result is going to still be a 3 by 3. All you're going to do is take each one of these terms and multiply them by 2. Every single one. There's 9 numbers there. You leave them as it is, and you multiply each one by 2. So 1 times 1, or 1 times 2 is 2. 3 times 2 is 6. 6 times 2 is 12. 4 times 2, and so on. So when that constant's out front, that's easy. Just go through here and multiply everything by 2. Now this one says multiply A times C. Multiplying 2 matrices is a little tricky. Okay. Now remember, we said this is a 3 by 1. You cannot multiply all matrices together. For example, I could not say do C times A. C times A will not work. Can't do it. It's impossible. But I can multiply A times C. And there's a reason why. When you multiply matrices, you should be able to take their size. A is a 3 by 3 times a 3 by 1. And write it out like this. It's like dominoes. If you've ever played dominoes, you know that to get 2 tiles to match up, they have to have the same number. Okay, so understand that? You know, if you got a 3 here, this has to be a 3, or they can't touch. You can't put a 3 and a 4 together. Doesn't work. You got to have it. If this is a 3, you got to have another domino tile that's a 3. Doesn't matter what's on the other side, just this has to be a 3. Same holds true here. Okay, when you're multiplying matrices, these 2 numbers in the middle have to match. That's why C times A wouldn't work. This would be a 3 by 1 times a 3 by 3. And these 2 don't match. But I can flip-flop it and it works. And it's because of the way we do it. Now, here's what's interesting. Since this is a 3 by 3 times a 3 by 1, here's the 2 that match. My resulting answer is going to be a 3 by 1. It's the bookends. Now, that's a really good trick to know because on the ACT, again, it's multiple choice answers. I can instantly look through the answers and go, okay, which ones are 3 by 1s, and eliminate all the rest. Yeah. So this one is very tricky in how you do it. And honestly, I'm not looking forward to having to write this out on the computer. So it's going to result in a 3 by 1. So that's going to be 3 rows and 1 column. I'm making this really, really big because there's a lot of math to do for one number. That's why I'm making it really, really wide. But again, it is 3 rows, 1 column. Okay? So what you do, we've got A times C. We're going to only look right now at column 1. Okay? Only looking at column 1. So you're going to do first term times, and then we got column C. First term in the first row times the first term in the first column. So it's going to be 1 times 3 plus second term in the column, 3 times 2. Oops, I did that. Plus third term, 6 times 4. So what do we get? We get 3 plus 6 plus 24. 24 plus 6 is 30 plus 3. That gives us what? 33. So our number is 33. Now we ignore this row and we're going to go to second row and do the exact same process. First term, and I'm not going to write out, 4 times 3 gives me 12 plus 2 times 2, which is 4, plus 1 times 4, which is 4. So I get a result of 20. Now I'm ignoring this row, and I'm only going to focus on the third row. 3 times 3 gives me 9, plus 5 times 2 gives me 10, plus 2 times 4 gives me 8, equals 27. So my resulting matrix here is 33, 20, 27. Yeah. And again, that's a lot to memorize. If I haven't done math in a while, I forget it. But you can literally take a TI-84 and go in there and say, okay, matrix A is a 3 by 3. The numbers are 1, 3, 6, 4, 2, 1, 3, 5, 2. Saves it. Matrix B is 3 by 3. Put in the numbers. Matrix C is a 3 by 1. Put in the numbers. And then you can go back many times and go, okay, A times B. A times C. Answer. C times A. Syntax error. Well, can't do it. A plus C, syntax error, can't do it. So once you put them in once, it can add them for you. So, I mean, it's kind of cheating. You don't have to remember the formula I just showed you, which is a lot to remember. Yeah. So, again, is it worth buying a $100 calculator to not have to memorize all that? If you're not good at memorizing, it's definitely worth the investment. I'm good at memorizing, and I still forget it. Now, the last thing we're going to talk about is the determinant of a matrix. And you can see this looks a lot like the absolute value, but it's a capital letter. So when they talk about a determinant, this is a 2 by 2 matrix, and they're labeled A, B, C, D as far as position. And to me, this looks a little like when you've got proportions, if you've got like X, Y, is equal to Z, A, you cross multiply and they're equal. I kind of think of that because here you do A times D minus B times C. And that's your determinant. You just have to know that formula. So here, if the determinant of this matrix is 15, what is X? Pause for a minute, see if you can use that determinant formula and get the answer. When you're done, unpause and I will go over it with you. All right, let's go back and let's look at this. So for the determinant, we do A times D. So X times X is X squared minus B times C, which is 1, and it should equal 15 because they actually gave you what it was. So we need to solve for X. How do I do this? Well, if I add 1 to both sides, I'm going to get X squared is equal to, got that, 16. So now when I take the square root of both sides, this is where you've got to remember, and again, scan your answers here, because it's not just 4. When we take the square root of 16, it can be plus or minus 4, okay? Because 4 times 4 is positive 16. So it can be either one. Okay, set your timer, set your watch, set your iPad, whatever you got to time you. Put 3 minutes on the clock and ready, set, go. Hit the pause button. Okay, you unpause, ready to check these answers that I know you got right. Sometimes I will, I shouldn't say sometimes, I should say a lot of the times, I forget. Is it rows then columns, columns then rows? I forget. So when I see a problem like this, I'm like, oh, I know the 2 middle numbers have to match. It's obvious this is a 2 by 2, no matter rows, columns, columns, row. So I know this has to be a 2 or they can't multiply. So it's rows versus columns. Yeah. So if I ever forget, sometimes there's a problem like that that helps me. So since this is a 2 by 2 times a 2 by 1, okay, these two have to match. So our result should be a 2 by 1. 2 rows, 1 column. Can't be this one, and it can't be that one. That's why that's kind of handy. So when we're multiplying again, it's going to be 2 times 4, which is 8, plus 1 times 2, which is 2. So our top number should be 10. I scan my answers. I can stop here. If I want to double check, 3 times 4 is 12, plus 4 times 2, which is 8, 20. Yeah, big star. I know I got it right. Again, if you have a calculator, can you plug both those in, multiply it? If you come to me and say, Miss Edwards, how do I do a matrices? I'm going to look at you and go, I have no idea. YouTube it. YouTube. How do you enter matrices on a TI-84 calculator? There's a YouTube video out there. Here, this one's nice because it actually gives you the determinant formula. So what must be the value for this matrix to have a determinant of negative 16? So again, A times D, we get x squared minus 8x. Oops, that was a wonky 8 equals negative 16. Now, this is Algebra 1, and I guarantee you some of y'all slept through this, or you've just forgotten it, or anytime I see an x squared and then like an 8x, I start to think back to quadratics. And that whole thing with FOIL and factoring and, you know, the x squared and all that. So I know I have to set it equal to 0. So let's get this 16. If I add 16 to both sides, then now all of a sudden I get x squared minus 8x plus 16 equals 0. So now I can factor. And if you had Miss Seals, I'm not sure how every Algebra 1 teacher teaches it, but this is one of the methods, which is called X factoring. You put the, what is it? This number on the top, C on the top, which is 16. You put B on the bottom, which is 8. What two numbers multiplied together equals 16, but when added together equal negative 8? So let's think about that. Is it 8 and 2? No. What about 4 and 4? Ooh, yeah. 4 times 4 gives me positive 16, but 4 plus 4 gives me positive 8. But what if I make them both negative? Negative 4 times negative 4 is positive 16. Negative 4 plus negative 4 gives me negative 8. So that means the factors here are going to be x minus 4 and x minus 4. You set these equal to 0, so x minus 4 equals 0. X minus 4 equals 0. So x must be equal to 4. Usually you get 2 answers in a quadratic, but these are the same, so your answer is 4. If you're unsure how to do this factoring like this with quadratics, if you slept through that lesson, maybe you were sick, maybe you were on vacation, it doesn't matter. Please come to me and let me know. I can give you worksheets on that because this is something you are going to be expected to know in geometry as well as Algebra 2. And it's really easy. I've got some great worksheets that I can help you with. Oops. So here we're multiplying. This is going to be, and I always write this out. This is a 2 by 3 times a 3 by 1. So there's my middle. So my result is going to be a 2 row by 1 column. That's a 1 row by 2 column. That's a 1 by 2. Okay. So I've eliminated 2. So same thing. Let's just do the first row. 3 times 1 is going to be 3 plus 2 times 2 is 4. 1 times 3 is 3. So I get 7, that's going to be 10. So the top number is 10. Not this guy. Okay. So now let's do the bottom one. 0 times 1 is 0. 4 times 2 is 8. 2 times 3 is 6, which gives us 14. Answer's A. Ha ha. You're awesome. Find the determinant. Again, if you got this one and you didn't know how to do it, flip back to this question. It gives you the formula. So 3 times 1 is 3 minus 4 times 2, which is 8, which gives you negative 5. Yay. And here is the last one. This does a little bit of combination. You're multiplying each one in the matrix by a constant and then adding them together. And we can add them together because they're both 2 by 2s and they're the same size, so we can add and subtract when they're the same size. So again, you're just going to go through here, multiply each one of these terms by 4, each one of these terms by 2. So we're going to get what? 4, 0, 8, 12 plus 4, 2, 6, 0. And then you just add them. 4 plus 4 is 8. 8 plus 2 is 10. I could almost stop there because if you look over at the answers, you got them, but I'm just going to keep going. And 12 plus 0 is 12. Yep. And so our answer is B. And again, if you have a calculator, my son could probably have input this into a calculator faster than I could have just solved it. I can't. I've never done it before. It would take me forever. So, exit ticket today. Exit ticket is, it says, can you add these two matrices? So this is a two-part question. So that's a yes and a no, and then a why or why not. So you can't just go, yeah, that's only, well, could be 5 points, could be 0, depends on if you're right or wrong. You have to tell me if the answer is yes, why they can be added. If the answer is no, you have to tell me why you cannot add them. So make sure you do both of them. And I've said it 100 times. I've handed you this answer. So if you're sitting here and you don't know it, you might need to go back and watch the video because definitely it's in the video. Can you add these two matrices? I want all 10s. Happy mathing, and I will see you tomorrow.